It's one of our parents to a couple other figures, the rhombus, the rectangle, and the square. So, what makes something a parallelogram? Opposite sides are parallel. So, the very first one, opposite sides are parallel. Okay, and then every once in a while I just use that parallel symbol, so just be aware of that. So, on the figure itself, I'm going to put arrows to signify, and then on the left and the right, I'm going to do double arrows because they are parallel to each other. So when we say this, opposite sides, we're saying both pairs of opposite sides. Okay? What else is true? They're congruent to each other. They're equal. Okay? So not only are they parallel, but they are congruent. So tick, tick, double tick, okay, for the tops and the bottom. All right? Okay. All right. What else is true? Opposite angles are going to be congruent. Okay. So I'm going to put up here, okay, some letters. Okay, just for future reference, if they ever talk about like parallelogram A, B, C, D, okay, it doesn't matter where you put the A. So if I were to put A in the bottom left-hand corner, I just always have to go in order. So if I went B, C, D, okay, I can't go A and then diagonally to B and then across C. You always have to go either clockwise or counterclockwise. Okay, so opposite angles are congruent. So what this is saying is that angle A is congruent to angle C and angle B is congruent to angle D. Okay, and we can mark that with our symbols to show that. Okay, that they are congruent. All right, consecutive angles. Consecutive angles refer to like angle A and angle B and angle A and angle D. What would be true about them in a parallelogram? Very good. They're supplementary. Okay, and if you need to, put down that supplementary means that they add up to 180 degrees. Okay, so an example. If angle A was 60 degrees, what would angle B be? 120. Now, based upon the fact that we said that opposite angles are congruent, then that means that angle D now is 120 degrees and angle C is 60 degrees. So that's why I said, like, when we talk about the consecutive angles, okay, it works, you know, left and right as well as up and down. It works both ways. Okay? All right, last one, diagonals, okay? Let's go with green this time, okay? The diagonals from A to C and then from B to D. What do you think is occurring with the diagonals? Think about some words that we filled in already. Are the diagonals parallel? No, because they intersect. Are they congruent? No, because BD looks like a heck of a lot shorter than AC, okay? So what could be true about them?
Intersecting like the middle.
Okay, so if they intersect at the middle of both of them, what are they doing? There's a word that I'm looking for.
Perpendicular.
They're not perpendicular. They will be perpendicular when we get to a square and a rhombus, but they're not for parallelograms. Okay, unless that parallelogram is a square or a rhombus. How about the fact that they, and this is I think what you mean by the middle, is they bisect each other. So this side is congruent to this side, and then this is congruent to here, okay? Now, I'm not saying that all four parts are congruent to each other. I'm saying that these two are congruent to each other, and then these two are congruent to each other. So, for example, if I put like an E as the intersection point, if AE was 5, what would EC be? Hopefully you're going to say 5. But BE, I might say, is 4. So what's ED? It would be 4, okay? But notice that the 5 and the 4 going across are not the same, okay? So they bisect each other, all right? So diagonals bisect each other, okay? And all we're going to do now is we're going to just take all of these properties. How come that didn't show up? All we're going to do is we're going to talk about you know, applying these concepts. All right, so first couple ones are pretty basic. All right, so if I asked for the value of C, what would you say? 34. Opposite sides are congruent. D, 27. Okay, we'll start with the easy one. What's angle B? 48. Opposite angles are congruent. So what's A? And how'd you get 132? Okay, 180 minus the 48 gave me the 132. Okay, remember consecutive angles are supplementary. All right, number 3. Here's the diagonals bisecting each other. What does H equal?
14.
What does G equal? Okay, so diagonals bisect and then opposite sides are congruent. All right, number 4. They tell us that VF is equal to 36. They tell us that EF is equal to 24 and EI is equal to 42. They want the perimeter of this triangle here, of NVI, which means I need to find the lengths of those 3 sides. Ideas. Kate.
Well, you're just writing like the 24 for first one for VI and EF.
Okay, so she says if EF is 24, VI is 24. Perfect. Okay? Other ideas? You want to keep going?
Yeah, sure. And like EI, since it's N bisects EI, and it's so if EI is 42, you just divide 42 by 2, which is 21.
Okay.
Which
So
makes NI 21.
okay, so both of these are 21. All right.
And then you just do the same with the VF.
Okay, since VF is 36, that makes each of these 18 and 18. So now the perimeter is 18 plus 24 plus 21. What do we get? 63? Anybody verify that? Yes? 63, 63, 63? All right, perfect. All right. So as you can see, all we're doing here is we're just applying the properties. And the only way they're going to make it more difficult is they're going to, you know, throw some x plus 2's in there, and you got to use algebra to do it. So this is technically 8.3. This is a completely separate section. Okay, but like I said, it's very redundant to what we've been talking about. Okay, so for this one, the goal is to do the converse. On the front side, I said if it is a parallelogram, then the diagonals bisect each other. But now, if I see in a picture that the diagonals bisect each other, then I can now say the quadrilateral is a parallelogram. And I'm just going to abbreviate with parallelogram. Hopefully that's okay with you guys. Okay? Because we're going to have to write it a bunch of times. All right, so if both pairs of opposite sides are blank, congruent, then it's a parallelogram. If both pairs of opposite sides are, what would you say? Well, we had congruent already. Oh, these are angles, sorry. Oh, both pairs of opposite sides are congruent, thank you, are congruent, then it's a parallelogram. Okay, and if both pairs of opposite sides are also parallel, because it's a parallelogram, then it's a parallelogram. Okay, and then if one pair of opposite sides, this is going to be a new one, okay, if at any time you get the following picture, one pair of parallel sides is both parallel and congruent, then it is a parallelogram. So you wouldn't have to show that both sets of sides are parallel. You wouldn't have to show both sets of sides are congruent. You would only have to show that one set of sides is both parallel and congruent. That makes it a parallelogram. Okay? All right, so again, going down to our examples. Number 6. What property are we using from above to show that this picture is a parallelogram? What about the opposite angles? All right, so you're telling me that this bottom angle here is 120 degrees? It's 120 degrees, 120 degrees, because we're doing some of the angles is 360, 360 minus 120 minus 60, all right? So now we would say because both pairs of opposite angles are congruent. Okay, that's the reason why. Okay, number 7. Why on number 7?
Opposite sides are congruent and parallel.
All right, so one pair, so instead of both pairs, one pair of opposite sides, parallel and congruent. Okay? And that's the 5th thing that we just talked about that we have a picture of above. Okay? All right, number 9 and 10. Using algebra, we're solving. Okay? So if this is a parallelogram, what x value would make it a parallelogram? Why 2?
Well, because the 6 and the 3x have to equal each other, and 3 times 2 is 6.
Okay, so 3x equals 6, x equals 2 if you divide by 3. All right? Who's got the y value? What'd you get for y?
5.
Okay. Why do you have 5?
Because when you add 2 plus 2 on the top, it's 4. And since those sides would be opposite, 5 minus 1 is 4, 2. And so it would be like that.
Okay, so she plugged the 2 in up at the top, figured out that the length was 4, and then set y minus 4 equal, or y minus 1 equal to 4. Add the 1 over, y is equal to 5. Okay? All right? See if you can do number 10 on your own. See what you come up with. All right, so are we understanding that since 2x is equal to 70, that x is equal to 35? I think most people had that. All right, ideas for solving for y. Julia, you get an idea?
I did 35 plus 3y equals 110.
Okay, so she figured out that the sum of these two angles is equal to 180. So if this one's 70, this one is 110. So, and then she plugged in her x value of 35 and said 35 plus 3y equals 110. Subtracted 35 over, divided by 3, and you got y is equal to 25. Okay? Now, that's not the only way that you could have done it. You could have, you know, plugged in 35, and then set those two equal to each other. It still would have worked. Okay? Questions?